Good afternoon, everyone, and welcome in this ninth session of the ongoing faculty development program. And today, our resource person will be Dr. Harmanpreet Singh Kapoor, Department of Mathematics and Statistics from Central University of Punjab, Bathinda, India. He will continue today's session on data analysis, social science, and humanities research. Without loss of any time, I would like to welcome Dr. Harmanpreet Singh Kapoor in this session, and welcome to all the participants who are showing interest in this ongoing faculty development program. Over to you, Dr. Kapoor, and
Thank you,
welcome in
sir.
this session.
Thank you, sir. Good afternoon, all of you. So I would like to thank again the organizer for giving me again the second opportunity to share my knowledge uh, with you. The screen is visible to you, right?
Yes, sir, fine.
Okay, fine. Thank you. So I will take 1 or 2 minutes to recap. It means what we have covered yesterday. So in the yesterday session, we have discussed about that a brief introduction about statistics and the major branches of statistics, that is descriptive and inferential one. Then we have covered the types of data set, in which we have discussed what is a qualitative data set, what is quantitative data set, and their branches also, right? And after that, there is a one important topic, that means the topic that we discussed yesterday, that was simple linear regression model. And before that, I have discussed with you that we need two variables, at least two variables, one for, and our main objective is to see the relationship between them, right? So first we observe the relationship between these two variables through graphical representation. And once we got to know that from the graphical representation, there must be some relationship exists between these two variables, then we try to find out the relationship in numerical form using Pearson correlation coefficient method. And I already told you that the value of the Pearson correlation coefficient always lies between -1 to 1. Okay. And then once we have the values of Pearson correlation coefficient, and we will try to figure out whether we can create a mathematical relationship between these two variables. Because till now what we have done, we first try to observe the relationship between any two variables x and y, and here we derive the mathematical, that means in mathematical sense, whether this relationship is very strong enough, whether the relationship is weak enough, whether they are negative correlated, whether they are positive correlated, through Pearson correlation coefficient. But now in the third stage, we have covered that whether we can say that one variable, it can be x or y, can be determined from the other variable or not. For that, we discuss some properties of regression. That means we first develop what is a mathematical relation we have in our regression, right? So these are the formulas that we already have covered yesterday: how to derive variance, covariance, then how to derive the correlation coefficient R. Okay, and what is the range? That means we have for correlation coefficient, and what's the meaning when we have correlation coefficient when it has value -1, 1, or 0. And these are some graphical graphs that shows different values of correlation coefficient, and you can use that. Okay, so these graphical representation also show whether relationship is linear, non-linear, but we have only focused upon linear relationship. Okay, and further what we have discussed, that what is a mathematical relationship, what is a mathematical equation for the linear regression model. So this is the mathematical equation. So there are various ways to write down. Either you can write down y is equal to alpha plus beta of x, but the meaning is amazing. Beta is a constant or intercept, and m is a slope or regression coefficient. Okay, then we also have discussed that after deriving the values of alpha and beta, our main objective is to see that whether our model satisfy all the assumptions or not of the model. So what are these assumptions? That the relationship between x and y is linear, and y is a normally distributed data set. The variance of y is constant. That means there must be no problem of heterogeneity, heteroscedasticity in the data set. The observation must be independent. and we have covered all these things. Okay, so now today what I'm going to do is I'm going to take one data set. Okay, let me scroll it down so that if there is any you can say question from the audience that someone wants to ask till stage what we have covered till now, one can ask. Otherwise, I'm going to show that how one can do this simple irrigation model in Excel first, then we will go with the on this R software. Okay, and we also have covered that what are the assumptions, how one can check the assumptions of the residual. Okay, for that we have different plots. From the plots, one can observe that whether the relationship between x and variables is linear or not, whether their homoscedasticity is there, and whether they are independent or not. Okay, so now without wasting time, so I have one data set with me in which there is a one variable income and second variable is happiness. And how many observation I have with me? Let me show it to you. So I have 498 observation. Okay, I have 498 observation with me. So what I'm going to do is now at the first stage, because first we want to see that whether the relationship is linear and whether there is any relationship exists between these two variables or not. Any voice is coming at the back end. Can you
So
mute yourself?
visually, ROP and Hosani RWT RC. So byanong kere maybe before truth na kahor kunale item ila ya coordinator ya women and convener. So relevant lot.
Okay. So what I'm going to do is I'm going to first see that there is any relationship exists between these two variables through graphical representation. So what I'm doing, I'm selecting these two variables. And in the Excel, I have to go to this tab insert. And if you're using, you can say Excel 2016 or 19, you may have these options directly. So because I have selected recommended charts, so what is the purpose of this or clicking on this tab is that it automatically decides which graphical method is more appropriate for a study. Okay, so now you can see that when I click on this, so I got this type of scatter diagram, and from the graphical representation, you can easily see that it means it is sloping upward, right? And there are various options also. You want to add access titles, data labels, error bar also. But I'm going to discuss that we just our main objective is to see that whether these two variables have some relationship or not, a linear relationship or not. So if you draw a line over this points, okay, you can see that most of the points lie on those straight line. Okay, so we can easily observe that the relationship is linear. My point is clear to all of you? Hello?
Clear, sir.
I'm getting some background noise. So can you mute yourself? Okay. So now the next thing what we have to do is we have to derive correlation coefficient, right? So I'm again going to select these two variables. Then I'm going to first go to this tab data. So if you are having this option data analysis, that is fine. Otherwise, I'm going to tell you that how you will get this option. So after this clicking on this tab, you can say, and you will have this pop-up and that shows these options. So there are various options are there: ANOVA, correlation, covariance, descriptive statistics, and other options are also there. Okay, so because we are interested in to derive the correlation, okay, so I'm clicking on it, then you can see that it will ask me the range of the variables. Okay, so I'm going to select these two variables. Okay, and they are grouped by columns, and there are labels in the first row because income and happiness are also there. And if you want output on the same sheet, then you have to click on this and then tell at which on which column you want this output. If you want to have this output on the next sheet, then it will show the output on the next worksheet or the new workbook also. Okay. Let me see what's the issue. I have to select it. So now you can see that it has given me that correlation coefficient between this income and happiness as 0.86. So that is very much close to 0.1. Okay, that we can easily observe through this graphic representation that happiness and income, they are linearly correlated, and the relationship is strong enough. That means strong linear correlation is there. All of you agree with me? And this value of 1 shows the correlation of income with income itself, and this happiness and happiness itself. That's why the value is coming as 1. Okay. So now we have cross-checked the first requirement, that from the graphical representation we have observed that there is some linear correlation exists between the linear relationship exists between these two variables. Then we have derived the correlation coefficient. And now what we are going to do is we are going to find out the regression. Okay, so I have one question for you. So among these two variables, income and happiness, okay, which one do you think that can be considered as a independent variable and other as a dependent variable? Can anybody answer this question?
Income is independent variable, while
Why
happiness
so?
is dependent variable.
So what is the logic? So you are saying that is correct, that is happiness should be considered as a dependent variable and income can be considered as a independent variable. But why? So on what basis you have decided this?
When we look at the two variables, it is the income that will determine how happy somebody is. Of course, if
Okay.
somebody has a lot of money, of course, it can bring happiness to the person. And
Okay.
if someone is without enough money, the person may be unhappy.
So basically, you can easily say that if someone has some income, then that person is able to have a good living. That means the person can maintain the living standard, right? So that
Yes,
increase
yes,
happiness also, right? But
yes.
that when the person is very wealthy, that doesn't lead to more happiness. It means happiness will be at a particular stage when you are able to cover up all your basic requirement for the living purpose, right? So now you can say that how we are going to build the regression. This means mathematical relationship between these two variables by considering happiness as a dependent variable and income as independent variable. So what you have to do is you have to go to this tab data, then you have to click on this data analysis option. Then this pop-up will appear, and in this you have to select this option regression. Okay. After selecting this regression, you again have a pop-up. Okay, so that pop-up will ask you that what is the range of y, that is dependent variable. Okay, so when I click on this option, so I have to select the variable y. Then again, I have to select this variable x. Okay, so because while selecting the dataset, I already have labels, that means income or happiness. and I do not assume that that my constant is 0. Constant means here is intercept. So I want that there must be some constant here that is non-zero. So there is an option that is called confident interval. So how many of you are aware about this term confident interval? Otherwise, I will explain it to you. Are you with me? Hello.
Yes, we have. Yes, yes.
Okay. So can anyone can explain the meaning of the term confidence interval?
The confidence interval can be the degree of confidence that we can have that our estimate is a true estimate.
Okay. So yesterday we have discussed one concept of beta, right? Do you remember that?
Yes.
Okay. This thing we have covered that there is a one parameter that is beta in this equation y is equal to alpha plus beta of x, right? So there are two ways to observe the values of beta. Either you can estimate the value of the beta from the sample that we have done in this case. That means we have estimated the value of beta by deriving the covariance between x and y variable and variance of x. What happened is when we have different data set, that means when we change our data set a little bit, either we can remove some of the variables or add some of the variables. Okay, the value of beta got changed a little bit. Okay, so what we need is we want that what is the range of beta that we have for this type of study. Okay, so we can say that our value of beta lie in that interval. So interval means here is what is the minimum value that beta can take and what is the maximum value that beta can take. So if we want to find out such an interval in which we can say that the true value of beta, that is parameter, lies with 95% confidence. Okay, so that is called 95% confidence interval. 95% comes from because we want our value of beta to lie in this interval with 95% probability or confidence, and interval because we are trying to construct a range under which this value of beta lies. The idea is clear?
Yes. It's clear.
Okay. So now output range. So where I want to show my output. First, either I have to show my output in on this sheet, or either I have to I want to show my output on different sheet. So if I want to show my output on the same sheet, then I have to click on this check on this option. Then I have to click on this. Then I have to specify the place where I want my output is. Okay. Now, so yesterday we have covered that there are some assumptions regarding residuals we have to cross check after making a linear regression model. So for that we need the values of residuals. What are residuals? Residuals are the values that shows the difference of y, that is true value of y minus y hat. That is the forecasted value or predicted value of the model. That means whatever the equation that we have constructed, how that equation value is different from the true value. Okay, so these are called those the difference is called residuals, and we have to check from the residual plots whatever the assumption that we have in our model, that is satisfied by the model or not. Okay, to the data set. Okay, because when we have different data set, that means whether our model still able to fit that data set easily or not. Okay, so now you can see that So what is the first term that we got? Multiple R. Can you see that? Hello. Can you
Yes,
see the
sir.
screen or not? Just tell me
Yes,
no.
yes, sir.
Okay. So now multiple R is, so now you can see that the value of the correlation coefficient that we have derived is equal to multiple R. Both are equal. Clear?
Yes, sir.
So that shows that correlation coefficient. Okay. The next is R square. So there is a one term that we haven't discussed till now. I kept it for today's session that we are going to discuss. That is called R square. Let me tell you that. Okay, R square. That is square of correlation coefficient. And this term R square, capital R square, is called coefficient of determination. What is the purpose of this term? Let me tell you. Okay, so now we want to see that we got the correlation coefficient value as 0.86, right? So we want to see that how efficient our model is. The which model that we have constructed by considering y, that is our happiness variable, alpha is intercept, beta is regression coefficient, and x is our income. How effective our this regression model is to explain the variation that is present in the happiness. So we got a value of R square as close to 0.74. So we can say that our model explains 74% of the variability present in the dataset. Okay, that means it explains only 74%. Why so? If you see the graph, so let us suppose if I'm going to construct a straight line here. So there are few observations. Those are far away from the this simple linear regression line. So that variation is not captured by this model. So rest of the variation is captured by this model. So we can say that approximately 74% of the variability is explained by this model. The idea is clear to you? Okay. So there is one more term that is called adjusted R square. I will come to that term again when we will discuss multiple linear regression model. But let me tell you in advance what is the meaning of adjusted R square. So there is some drawback of coefficient determination, that is R square. That drawback is that when we keep adding on some variables in this model, okay, the value of R square keep on increasing. That doesn't show the actual benefit that we got after adding new variables in this model. Okay, to observe the actual variation that is explained by the model by adding new variables, for that we will only study adjusted R square. Okay, so further we have standard error. So yesterday we have discussed the definition of standard error. Standard error is basically standard when we divide our standard deviation with this number of square root of number of observation, that is called standard error. And how many observations we have in our data set? 490 that I already have discussed with you. Now coming to this ANOVA table, okay, that is very important. So in our you can say we have two variables, right? So we have constructed one regression equation, okay, that consists of two parameters, alpha and beta. Okay, so there is a loss of 1 degree of freedom. So we have two parameters and we reduce one parameter because there is a concept that while fitting this ANOVA, so there is a one loss of degree of freedom. So how many observations we have in total? 498. So you can see that total degree of freedom is left is 497, and the remaining degree of freedom will be go to residual term. Okay, so I'm going to show you that what are these values. So if you remember yesterday discussion, I have discussed with you that the variation of observation from its mean value is can be written in terms of sum of square of regression and sum of square of residuals. Okay, so what is the total sum of square? Total sum of square shows each observation deviation from its mean value and then taking the square and adding them. Okay, and this overall variability can be split further in terms of sum of square of regression and sum of square of residual. So in sum of square regression, you can see that yi hat that shows the fitted, or you can say fitted model. Now we are observing the fitted model deviation from its mean value. Okay, and here we are observing that how much variation we have, that means residuals. So for example, you can see that yi hat shows the fitted model value of y, and here yi is a true value. So how much difference shows? That is the value of residual. So when you take the square of each residual observation, then add it over the all number of observation, that will be your sum of square of residuals. And sum of square regression, that will be the fitted value of y, a deviation from the mean value, and then taking the square and adding them. So here you can see from the output that this equation shows sum of this regression, this corresponding to regression row, we have sum of square of value that shows sum of square of regression. This value shows sum of square of residuals, and this is the overall variation. Okay, so for a good model, we want the sum of square residual to be as small as possible. The reason is, when we have very large deviation of, that means we have large value of residue, so it means that our model is not good enough to forecast, or you can say fit the value of yi accurately. So we want this residue to be as small as possible and sum of your residue to be as small as possible. So now you can see that on the right hand side we have values further. Let me just drag them. Okay, so this value of f, that is called f statistics value, and that one can derive this value by dividing these two terms. That is called mean sum of square regression, mean sum of square residual. So I am going to tell you how one can derive this value, mean sum of square regression or mean sum of square residual. You have to divide sum of square with their degree of freedom. So you can see that when I divide 764.546 by 1, you get the same term. But when I divide 255.77 by 496, you will get this term. Okay, and when you take the proportion of these two terms, when you have the proportion of these two terms, you have this value f 1482.632077. Okay, so now what we do is we have to make, you can say, we have to make a statement regarding this regression model, whether this regression model is efficient enough to fit the data set or not. So for that, we assume that this regression model is not good enough. That is our null hypothesis, and this regression model is good enough. Or we can say that the regression model does not explain the variation present in the data set efficiently. And the alternative one is this regression model explains the variation present in the data set efficiently. Okay, in the null hypothesis, we assume do not, and alternative one, we assume that it explains. So here you can see that the p-value is coming as less than 0.05. And in my yesterday discussion, I already told you that our main objective is to see whether our assumptions regarding the regression equation or coefficient, that is significant or not. Okay, so we have discussed this also, that we want our p-value to be significant. That shows that the in this case, that shows that our beta is non-zero. But in this ANOVA table, we are we have this null hypothesis that our regression equation is efficient or not to explain the variation. So if we are rejecting our null hypothesis, that means our regression model is efficient to explain the variation present in the dependent variable, that is happiness here. Okay, so now further in the next table, what we have a term that is called intercept and income. Why so? Because we have assumed income as a independent variable and intercept is a constant term. So this value shows the intercept value, the coefficient, that is alpha hat. Okay. Yeah, in the yesterday we already have discussed how one can derive the coefficient of alpha and beta. For that, I have these are the formulas. One can derive the value of alpha by putting the value, that is, first one has to derive y bar. Then we also already need the value of beta hat and x bar. When you put the values in this formula, you will get the value of alpha hat. And but here in the regression, we in this Excel, we are getting the values of alpha hat here, and this value shows the values of beta hat. Okay, and when we divide our coefficient by the standard error, you will get the value of test statistics. Okay, and here the test statistics, t statistics. And further again, the null hypotheses are h naught, whether alpha is equal to 0, alternative one is alpha is not equal to 0, and h naught dash is beta is equal to 0, or h1 dash is beta is not equal to 0. So here you can see that in both of the cases, for alpha and beta, both are coming, p value is coming less than 0.05. So we can say that we are going to reject this null hypothesis. Okay, clear? Till this stage, if someone has any doubt, because this topic is very important, and maybe some of you are not aware about the testing of hypothesis. So I'm going to try my best to give you the understanding of this topic as easy as possible. Is it clear?
Yes,
Hello?
sir.
Okay. So now you have seen that both the coefficients alpha and beta, they are coming significant. Now in the next step, what we have the values of the confidence interval. Okay, so now you can see that the lower value of this alpha can take is 0.029, and the maximum value this alpha can take is 0.3788. So we can say that the alpha parameter, alpha hat, or true value of population parameter alpha lie in this range. Okay. And similarly, we can say that the true value of beta lie in this range 0.67740 and 0.7502495. So what is the purpose of this 95% confidence interval? That is again very helpful to determine whether our coefficients are significant or not. Just from the confidence interval, you can make a statement that in this confidence interval, there is no value of 0. That means 0 doesn't lie in this interval, in both of these intervals, right? If 0 is absent in this interval, then we can say that this alpha and beta, both parameters are significant. That means they are playing their role by determining the values of the dependent variable, that is happiness here. Is it clear? Okay, so now moving ahead. So as already discussed with you, that how one can get the values of residues. So for that, what we have done here is, so these are the values of yi hat. That's why it is written as predicted happiness. So we derive these values, okay, by putting the value of alpha hat, beta hat, then x that is given to us. That is the value of, put the value of income variable here and the values of alpha beta from above, and we got this value of yi hat. Okay, and we now take the difference of this yi value hat with true value of yi minus yi hat. Okay, so whatever the difference will come, that will be the value of residuals. Okay, so you can see that some of the residuals are positive, some of the residuals are negative. So there is one property that when you add these all residues, the sum should be equal to 0. This is one of the property. So that is all that always satisfy. So let us suppose I am taking the sum of okay, I have to write down. Okay. So now you can see that while doing the summation, I got the answer that is very, very close to 0. Why so? So what do you mean by this 2.42 e power minus 13? It means that 2.42 10 power minus 13. So we have approximately 12 zeros. Then we got this answer. So that is approximately close to 0. Okay, the idea is clear to you, right? So next, we have probability values. What are the percentiles and correspondingly happiness values. So I also want to see where are the plots, whether they have constructed those plot here or not. They are not showing the plots in Excel. Okay, I'm not able to understand why they have not shown it. It must be there. Okay, otherwise I will show it in R. When we do coding in R, I will explain to you. So till this stage, if someone has any doubt, one can ask me. And how you will get this package data analysis? For that, whatever the version of Excel that you are using, so you have to click on this customize quick access toolbar, then go to this more command. Okay, this pop-up will appear. Then you have to go to this option add-ins. Okay, so there is an option analysis tool pack. You have to check, you have to click on it and then click OK. Okay, and you have to also manage that it should be Excel add-in. Then click on it. Okay, this option will appear to you on your tab under this data option. This is clear? Till this stage, if someone has any doubt, one can ask me.
Sorry, sir, can you repeat that process again, sir?
Okay, so what I was saying that, so if you want to have this option on in your Excel, you have to click on this, right, customize quick access toolbar, then go to more command. So all of you are able to have this pop up. Right? Then click on add-ins. Then click on analysis tool pack. Okay. Then OK. Let me try again whether it again shows that plots or not. Now they are showing here. Okay. Can you see the screen, right?
Yes, sir.
Okay. So what are the assumptions that we have discussed yesterday regarding residual plot? That there must be no any trend while plotting the residuals over the x-axis. So there is no any trend is coming. All the observation either on the positive side or either on the negative side, right? Can you see this? Okay. And there is no any issue of homoscedasticity. Okay. If you remember yesterday, from the yesterday discussion, we have discussed that from the graphical representation shows that the residuals, they are linear if they are scattered. There is no any pattern there. So this condition is satisfied our mod in our model. The second assumption is residual analysis for homoscedasticity, that there is no any increasing trend like this one. Okay. In the residuals, we have constant variance that is also satisfied in our plot. So these two conditions are satisfied. So here you can also see that our predicted happiness, that is equation, linear regression equation, okay, that fits the data set. That means fits the happiness values very in a good manner. That's why we are getting value of R square coefficient determination as 0.749. Okay, and to cross check the assumption of normal, whether our data set satisfy the condition of normality or not, we need normal probability plot. It is also called PP plot or QQ plot. So what is the requirement? That we want our data set should be on the straight line like this one. Okay, there must be some band is there, and that is acceptable in the case of when we have a large number of observation. In our case, we have approximately 500 observation. So in that case, that works. But so for the case of very small number of observation, and most of the points, they are not on the line. So that means we do not have the assumption of normality. That means our data set do not follow normal distribution. Okay, so in that case, we can't implement simple linear regression model. Clear? So every step is clear till this stage, but we have discussed how to do the simple linear regression model in Excel.
Yes, sir.
Okay. So now I'm going to take that means I'm going to do the same analysis, but in R. So before going to discuss that how one can do the analysis in R, let me introduce is what is R and what environment. So basically this window that I'm using, that is called R Studio, and this is called user friendly interface of R. So basically this is not the you can say graphic representation of R software. This is the R Studio that you use the R language at the backend for the analysis purpose. Okay, so you can see that when I click on this file option, file tab, so first you have to go to this R script. Okay, when you will go to this R script, you have a new blank space where you can type your code, right? I already have written this code to save the time. Okay, that is already written here. So here, this is a editor where you can type your code. And here you can see that at the bottom, we have a console where you will see your output. Okay, and on the right hand side top one, we have environment that shows that whatever the variables that you're calling to the environment of R, that is shown here. If I will show it to you that if I call this dataset 2, so whatever the values we have in that dataset, that is shown here. Okay, and this top bottom right, we have this different options that shows that where is your directory. Directory means where you have stored your files, in which you can say folder you are working, right? And here I will see my plots. What are the plots I will draw? I can see those plots here. Packages means, so let us suppose if I want to do some a particular type of operation, for that I have to call that package first. Then only I can do those operations. And this is entirely, you can say program. That means R is a entirely coding language. That means coding software, you can say. Here we can't do the operations by clicking. That means like in the Excel, we have to just select some option and you will get the output. But in R, you have to write down the code to do the analysis purpose. This thing is clear? And you can, and if you want to find a code for a particular function, that means if I want to do, if you I want to derive the mean of the observations, then I have to just type the keyword, then automatically shows you that how you can derive the mean of the variable and other things. And viewers and presentations are different options that can only in that tab you can only see the output when you are using a particular type of format for the analysis purpose. For example, I can create a PPT from the R software. I can also create HTML document from the R software. I can also create PDF document directly. So I'm not going to discuss those things at this stage because this is the first time we are introducing R. So here, so now you can see that I already have used R for some of my research work. So I want that I want to clear the memory. That means whatever the information I have stored earlier in my R software, I want to clear that. For that, I have to use this syntax RM bracket open list is equal to ls. So when I click my cursor on this option RM, you have seen some pop-up appears, right? So for example, I have just take my cursor to any of this option. So it is also give me that what are the okay, let us see. I am going to show it again. So what is the meaning of RM? That helps me, R Studio helps me to see what are the other options I have in this that function. I have to keep this here. That may show. For example, here you can see when I keep my cursor on read.csv, so it shows me that first you have to put your file name, comma, header, whether you want to keep the name of the variables, okay, and then whether that file has any separators. So these are the arguments. That means one has to pick those arguments as per his or her requirement. For example, I just want to execute this command that I want to clear this memory of R, okay, because I want to execute a new program. Then what I do is I can click on the right hand side, either I can click run here, and you can see that the environment is empty now. That means I am ready to work on my R, you can say software, where there is no any prior information stored, right? So there is the first option is either you can click on this or either you can use this command control plus enter. Both will work the same thing. Okay. So either I put my cursor here, I am using this command control plus enter. So that will give me again the same output. Okay. And whatever the packages that we are going to use to draw graph and other things. So the name of the packages I already have written for you. That means I need a package that is called ggplot for the graphic representation. I need a package dplyr. I need a package broom. I need a package ggpubr. So basically, you do not have to remember the name of these packages. The thing is, you just have to you can say see the code, and they automatically ask you that this package is required for this particular type of task. Okay, and with practice you just remember that these are the packages that is required for the analysis purpose of simple regression model. Okay, so I already have installed these packages. So if you are using this R software, you first have to install these packages in your R Studio, right? And the installation is very easy. You have to click on this packages option here, Then you have to go to install. You have to just write down the name of the package. Let us suppose I just write down GG. So it gives me an option. Okay, so ggplot2, I click on it. Then you have to check this box, that is install dependency. Then click on this install, because I already have installed this package, so I'm not going to install it again. Okay, so after installing these packages, you have to call them for a particular type of operation. So I already have executed a command that to clear my memory. My environment is empty, so there is no any prior information stored in the memory of R. So I'm going to call these packages one by one by clicking by using this command control plus enter. I have executed one, so you can see that library ggplot has been called in the memory of R. Although it is not shown here, because here it will only shows the name of the variables that we are going to data set and what are the variables they have, what type of information they have. So it is be shown here. So now you can see that when I execute this command deployer, so they are already attaching a package that is called stats. Okay, because stats is the main package that is required to do this you can say fitting this linear regression model. Okay, when I call this package broom and gg pubr, so now the next thing is I want to call the data set. So you can see that this is a path I have assigned for calling this data set. Okay, the data set is income.data. So there are two options for calling the data set in R. The first option is you can call the data set in terms of XLX, that means Excel format, or CSV format. So I am using a CSV format data set. Okay, so first I have converted my data set to CSV file. Then I use a command read.csv. And then I have assigned the path, that this is the path of my where I have stored my file. So this is the path. So when I execute my command data to, so you can see that in this I got three variables, and this is a syntax of assigning whatever the data set I have called, that is assigned to this variable name data2. So you can assign any other variable name, data1, data, and income data, any name you can assign it to. So now you can see that on the right hand side, this environment, this data2 has been shown here. So when I click on it, you can see that. So we have three variables, 1, 2, 3 will show the numbering, because in the Excel file, you can also see that in the sheet 1, in the income file, okay, that is shown on the right, very right. That's why we are not able to see. So there is one variable that consists of the number of population 1, 2, 3. So R has considered as a separate variable. That's why it is showing under the variable name as X. That is assigned by R, not by us. Okay. So it consists the number of observations we have in our data set. So we have second variable income, third variable is happiness. Okay, so it consists of same number of observation that we have in Excel, 498, that is already shown here. So now I'm going back to my this R console where we are going to execute it. So first I want to see that what type of information we have for these variables. So there is a syntax, or you can say function we have, that is called summary. So what summary gives me? So I'm using this function summary, under which I'm calling this variable name data2, in which I have stored this data that consists of two variables, income and happiness, and X variable that consists of number of number of observations we have. So when I execute this command, you can see that it shows me output. It shows me output for three variables. Why so? Because it considers the first variable in which the number of observations are written. It considers that as separate variable. So you can ignore this variable also. That is not relevant for us, variable X. But our main requirement is we want to see that what type of values we got corresponding to this variable income and happiness. So you can see the minimum value that income variable consists is 1.506. The first quartile is 3.006. The median is 4.426, and so on. So Do you know what is first quartile and third quartile? Hello.
No, sir.
Okay, let me explain to you also. So the idea about median is clear to all of you, right? The idea about median. What is median? Hello.
That would be the middle observation.
Okay. So let us suppose we have data set with us, and I have arranged the observation in this on this line. You can say. Clear? This thing is clear. So there is a one value that divide this whole data set, because I have arranged the data set in increasing order. So which value that divide the whole data set in two equal parts? That is the value of median, right? So we generally assume that median is the value that divides the whole data set into equal parts. So 50% of the observation are on the left hand side and 50% of the observation on the right hand side. Is it clear?
Yes, sir.
Okay. So there is a one more term that is called quartiles. So quartiles are those observations that divide the whole data set into four equal parts. Okay. The first part will consist of 25% of the observation. The second part will consist of the next 25% observations. So next 25%, the last 25%. Okay, clear? So any value that divide the data set into first quartile, that is called Q1, quartile 1. Okay, that means there are 25% of the observation that is below this value of Q1. The next quartile is called Q2. So it consists of 50% of the observation that is below to this observation. So that is again equal to median. So there is one person whose mic is unmute. So can you mute yourself? Okay. So now, so what we have discussed till now, Q1 is that observation that consists of value in which 25% of the observation are below this value, and median is that value that divide the data set into equal parts. So it means 50% of the observation are below are on the left hand side and 50% of the observation on the right hand side. Okay. The next category is Q3. It means 75% of the observations are less than this Q3. Okay, is it clear? The idea is clear to you? So in this way, in the quartiles, we have divided the whole data set into four equal parts. The first part is this one, the second part is this one, third part is this one, and fourth part is this one. So that's why quartiles are very important for the analysis purpose, to see that how much which observation it means are helpful for dividing the whole data set into different parts. Okay, and we also want to see that how much variation we have in our observations that can be easily be observed through this value of max and minimum. So what is a you can see the maximum value is 7.482 and minimum value is 1.506. So it means the variation is very high. That is around 6 point something or 5 point something, right? Similarly, we can see the summary corresponding to this happiness variable, in which we got minimum value as 0.266. The first quartile is 2.266 and so on. Maximum value 6.863. So you can observe that there is a huge variation that we have in our data set of happiness also. Okay, till this stage, everything is fine. Okay, so now if I want to see that what are the observations we have in our data set. So the first option is either you can click on this right hand side data and you can see the data whole data set. But if I just want to see few observations, what what are the few observations we have in our data set? So there is a command that is called head that shows the first few rows of the data set. Okay. Now further, I have a command that is called histogram. Okay. So I want to create a histogram for my variable happiness. Why so? Because we have this assumption that our data set should be normal, right? And one can easily be observe the normality of the data set by plotting the histogram first. Okay, most of you are very much familiar that histogram are such types, right? So when we join a line over this midpoint of this histogram, so if it is coming to be a bell-shaped curve, we can say that our data set is of normal shape. Okay, and if there are histograms, they are of such forms. Okay, when we join these points, midpoint of this histogram, and the data set is not coming to be a bell-shaped curve, then we can say that they are not symmetric. Either they can be positive skewed or either they can be negative skewed. So I'm taking one more example. Okay, so let us suppose I'm taking this example. So you can see that the shape of, there are three shapes only. The first shape is positive skewed, oh, no, sorry, symmetry. This is the shape of the positive skewed curve, and this is the shape of negative skewed curve. Okay, to cross check what type of data set, what type of shape of the distribution we have for variable happiness, we execute this command, and you can see that the output is for the plot is on the right hand side. When I click on zoom, you can see this output. And when we join a line over this histogram, okay, it seems to be normal. It seems to be normal. Why so? Because there are few you can say bars that is not very high enough to cover up the normal curve. But when you join them and keep them as it seems to be bell-shaped curve. And when we have a large data set, so in statistics, we assume that for large data set, most of the each and every data set follow normal distribution. That is only relevant for the case of large data set. That means here we have 500 observations, so we can say that our data set follow normal distribution. Okay, if you want to cross check it, there are tests available, but I'm not going to, you can say, discuss those things at this stage. Okay, so now I want to plot happiness corresponding to income. I want to plot a scatter plot. So here the syntax is plot. So plot will show you the scatter plot here. So I am keeping happiness as a dependent variable and income as independent variable, and I'm calling a data at data2 because I have stored my observation in data2. Okay, so when I execute this, you can see that so from the scatter plot that they are increasing, they are sloping upward, right? So from this graphic representation, you can say that so there is a strong relationship exists between happiness and income, just like we have discussed in the Excel. So there is another way one can see the relationship between happiness and income, okay, of this data set using our program. Okay. Okay. So now I want to know, we already have discussed about the relationship of these two variables. If I want to derive the correlation value between these two variables, happiness and income. Let me see whether this function will work. Okay. So I got on my same answer as it is like the answer we got in the Excel that there is a strong relationship exists between these two variables and the correlation coefficient is coming as 0.8656. Okay, and to now our main objective is we want to fit the regression equation. So what I'm doing here is I'm using a function that is called lm. So when I have selected this function, you can see a pop-up appears that shows that you first have to write down the formula, then the data and other options. So I'm just using first two options. In the first option, I'm using my variable that is dependent variable, that is my happiness here, the second variable that is income, and this tilt symbol shows that on the right hand side whatever the variables I'm going to take, that is independent variable, and whatever the variable I have shown on the left hand side, that is dependent variable. So when I execute this command by using this option control plus enter, okay, and then because I have stored my values in income or happiness, so I got this output, intercept and coefficient of intercept and coefficient of income. So you can see that the same or output that we have derived from the Excel, I got intercept coefficient as 20 something and income coefficient at 0.7138. Okay, but I want to see the overall analysis like we have seen in the Excel. So for that, I have to use this function that is called summary. Now I am taking summary of the variable in which I have executed my regression equation. That means whatever the regression equation function that I have executed, I have stored that model in a variable name income.happiness.lm. Now I want to derive the summary of that variable. So when I execute this command, you can see that the output is coming now as it is. So we first have the coefficients. This is the coefficient for intercept. This is the coefficient for income, that is also called regression coefficient. And we have standard error for both these coefficients. Then we have t value. Okay, then these are the p values that we already have discussed in Excel. Both are coming significant, but the beauty is that in R they also put some asterisks. So this asterisk show that this is significant at 5% level of significance. This is significant at 1%, even 1% level of significance. So basically what the meaning of this thing is, so the coefficient of P, that means the coefficient of intercept, the intercept value and the p value corresponding to this coefficient is coming as 0.02, that is less than 0.05. So that's why one asterisk is put here. So here you can see that this coefficient is less than, the p value of this coefficient is less than 0.001. So that's why three asterisks has been put. Okay, it is already mentioned the meaning of this asterisk. So that 0.05 we have asterisk, one asterisk, 0.01 we have two asterisk. When we have three asterisk means that it is 0.001, it is less than 0.01. So it means they are highly significant. Okay, similarly we have residual standard error that we have already discussed in this Excel. We got multiple R square, that is 0.7493. This is same value that we have discussed in Excel. Adjusted R square, I already have discussed the difference of this R square and adjusted R square. So the F statistics value, the same value of F statistics 1483 that we have discussed in Excel, and their degree of freedom and the p value, all the things are same, but the only thing is that here you have to just write a code for this for the analysis purpose, but in the Excel just have to click on the options to get the answer. So till this stage, if any doubt is there, otherwise I'm going to start discussing a topic that is multiple linear regression. Should I continue or you have anything to discuss? Hello.
You can continue, sir.
Okay, fine, thank you. So yesterday we have discussed that there are two variables, and there is one variable that impacts the value of other variable. But now we are going to discuss that in real life, no single variable can determine the value of the other variable very accurately or 100%. So there must be some difference or some gap is there. So to cover up those gaps, so what we do is we consider not one variable. Okay, we consider more than one variable. Okay, so if you remember the last example that we have discussed, that to observe DSST score, okay, we consider one variable that was vitamin D. So what was the objective? That to observe the cognitive functioning of the human brain. Okay, we have considered one analysis in which they have derived the values of DST score, and the values of DST score lies in the range of 0 to 60, right? And they have considered only one variable, that was vitamin D, and we want to see that how this value of vitamin D is helpful for determining the value of DST score. But as now just discussed with you, that there is no single variable that completely determine the value of dependent variable. So what we do is we add more important variables to reduce our error term or residual values. So for that, what we do is we consider intercept as it is. So we consider one variable, we consider one more variable, and this addition of variable, that depends upon the objective. So if there is by adding one more variable you are getting good result, then you can stop here. But if you are still getting not good result, then you add one more variable. And when you will stop, but you can say when you will think that whether I have to stop here or whether I have to continue adding one more variable, for that we cross check the value of adjusted R square. If there is any improvement in the adjusted R square value by adding new variable, then we keep that variable. If there is no any improvement by adding that variable in this adjusted R square, then we skip that variable also. Okay, we will discuss about that. So the concept is clear that what is the difference between simple linear regression and multiple linear regression. In the simple linear regression, we have one independent variable and other dependent variable, and they are linearly related to each other. But in the multiple linear regression model, we have more than one explanatory variables. Why I'm saying explanatory variables? Because it may happen that these variables are related to each other. That means x1, x2, or x1, x3. So that may bring the problem of multicollinearity. Although this is not the topic that I am going to discuss today, but for the time being, I am assuming that this x1, x2, x3, they are independent of each other. Independent means that whatever the value of x3, that not impact the value of x2 or x1. Similarly, x1 not impact the value of x2 and x3 and so on. Okay, so that's why here we are discussing whatever the model we are going to discuss, we are just assuming that all these three variables, they are independent to each other. Okay, so here you can see the graphical representation of variable here, in which we have considered two variables, age and vitamin D. Okay, and on the right hand side, that means explanatory variables, and DSST score on the left hand side, that is dependent variable. So this is a graphical representation, and you can see that most of the observations seems to be scattered. Okay, they are not, or you can say seems to be going on the right hand side, they are not seems to be going on direction, but still we can see that there's some relationship exists, because if I draw a line in this manner, most of these points they can be assumed to be lie on this line. So I can go with my regression model, and this is a 3D view. And in this 3D view, you can see that it seems to be of downward sloping. Okay, to observe that whether this relationship is positive or negative, because it may possible that with age, because we have considered two variables, vitamin D and age, and with age the value of DSST score may decreased. That's why this shape will be of you can say negative side. So negative side means downward sloping shape, right? So we have a plane that also shows the same thing. This again a graphic representation. So I'm not going to discuss because we have lack of time. So now what we have is we have fitted equation. So where I got these values after fitting this model, and we got this value of alpha hat, beta 1 hat, and beta 2 hat from the Excel, or you can say any other software. Okay, so now you can see that what this value shows. So you can see that on average, if we assume zero value of vitamin D and the person age is a newborn baby, so that's why in that case we put age as 0. So the person born with the DSST score as 53. So this is the meaning of this thing, right? A person who's a newborn baby has a 0 value of vitamin D, has at least 53 value of DSST score, and with increase in age, this value keeps on decreasing because we have a negative sign here. Okay, so it means, so if there is a one increment of age, so that leads to 0.46, that means 46% decline in the value of DST score. Okay, but when we, and with increase in age, the person also consumes some vitamin D, so that will increase the value of DST score further because we have a positive sign. And we have, after fitting the model, we have observed that the value of vitamin D is coming to be non-significant, but the value of p value for the coefficient of age is coming to be significant. But earlier in the previous model, when we have taken only vitamin D and vitamin D and DSST score, okay, the relationship was significant. But what happened when we add a new variable, age? So it means that there must be some connection between vitamin D and age. We have to observe that. That means, because we want this assumption that these two variables should be independent of each other. So this thing is not going to happen here. So that means we have a problem of confounding here. Okay. So now, so we are going to discuss that how one can generalize the result of this simple linear regression model. This is a mathematical form that we have intercept term here. Then we have beta 1, beta 2, beta 3. That means in spite of considering two variables, I am considering three variables here. Okay, and this coefficient shows a 1 unit change. That means if there is a one increment of 1 unit in x, how much this increment will be you can say impacted the value of y. That is depend upon the values of this beta 1, beta 2, beta 3. If they are greater than 1, so increment in value of x will lead to more increment in the value of y. If they are greater than 1, if they are less than 1, that means then the increment in value of y in x will lead to less than 1 increment in the value of y. Okay, so I'm going to skip this because it is better if I directly go to this coding part in Excel and okay. So I'm going to skip at this moment. So if I get time, then I will discuss the theory part. So I have another data set with me, that is herd data, in which I have three variables. One is biking, second is smoking, and herd disease. So here the values are continuous. I have observed a continuous value data set only, and so here my dependent variable is herd disease. So basically what we are trying to observe that whether the person who are having herd disease that is affected through biking or smoking. The idea is clear? Hello?
Yes, sir. Yes, sir.
Okay, thank you. So when I want to see from the graphic representation, so in Excel we can only draw two plots at a time. That means two variables in a single plot. So what I'm doing is I'm considering one variable bike, another variable Let me see. Okay, recommended charts. Okay, so now you can see this plot. Okay, so what you have observed from this plot? The relationship is there among these two variables. Yes or no? And what type of
Yes.
relationship they have? They have negative relationship, right? That means
Yes.
increase in one value will lead to decrease in other value, right? That's they have downward sloping curve. So let me see the relationship between this another variable smoking and heart disease together. So when I plot these two variables, the relationship is not very obvious, right? Because although it seems to be upward sloping curve, upward sloping, but the observations are very scattered, right? So what we are going to do is we will derive the correlation coefficient among these two variables, because correlation can only be derived among two variables at a time. There is some issue with this input range. I think I have to take this column separate table, then only it will help. Let me do it.
अरे अरे हेलो भाई साहब, ये हटाओ यार पत्थर पर।
The output has come. I have to see where the output is. Okay, so this is the output. So you can see that the output is coming as a negative for to observe the relationship between heart disease and biking. Right, that is negative 0.93546. Right, and to observe that the correlation between two variables, smoking and heart disease, is I have to select it is coming as 0.309131. So because the value of this correlation coefficient among this heart disease and smoking is very small, it is not very close to 1, but close to 0, or you can say less than 0.5. So that's why from the graphic representation we have observed scatterness in the observations. Okay, but now our main objective is to see the regression relationship among these two variables. For that, I have selected this option regression. Then I will select my dependent variable again. And input range, I will consider both variables together. Okay, I'm not assuming constant is 0. So I want my output to be on new sheet. I want residuals. Okay, let us see. Okay, there must be issue with the reference. Now everything is done. So this is the output. So here you got your multiple R, that is regression of this correlation coefficient jointly, that is derived from the model as 98%. And R square is coming as 97. That means this model explains 97% of the variation present in the data set. Okay, and we got adjusted value of R square also close to 97%, so that is fine. So we have for a 98 observation in this data set also. So here you can see that the regression coefficient is 2. As already discussed earlier, that whenever how many parameters we have. So here we have parameters alpha, beta 1, beta 2. So we will reduce 1 degree of freedom. So that's why we have 2 degree of freedom here for the regression coefficient. And total we have 498 observation. So we will consider 497 observation in the total. And when we subtract this 2 from 497, whatever the remaining observations or degree of freedom is left, that is for the residual term. And also how one can derive the sum of square of for regression residual. So we already have discussed these two things. And mean sum of square is derived by dividing the sum of square by 2. You will get this value. And for this, the mean sum of square residual is derived by dividing sum of square of 211.7403 by 495. And the ratio of these two terms will give you the value of f. And here you can see that the f value is coming as 0. That is very highly significant. Okay. Now the next step is we want to see the coefficients. That means what is the value of intercept? That is alpha. That is coming as 14.98. What is the coefficient for biking? That is the regression coefficient for biking variable, that is coming as minus 0. Because biking and heart disease, they are negative related to each other. So if people do more biking, they are less prone to heart disease. So but the smoking and heart disease, they are positive related. That means if person do more smoking, there are chances that the person is having heart disease, right? So further we have standard error term. We have the value of test statistics. We have the value of P, and most of the value of P is less than 0.05 5, 0.01, 0.001 also. They are highly significant. Okay, so intercept is significant, biking coefficient is significant, smoking coefficient is significant. And then further we have their confidence interval that the value of alpha lies in the range of 14.82 and 15.142. And the coefficient for biking lies in the range of minus 0.2028 and minus 0.197 and so on. For the smoking, we have this regression coefficient lie in this range. So similarly, these are the forecasted value that we got from the model, and how much residual you got. You can see that the residual is coming very minimum. Most of the values are in the terms of zeros only, and when you add them, the answer is again coming to be 0. Okay. Now coming to this graphical representation. So normal probability plot is a straight line, that is good symptom. And this is the equation, this is the graphical representation at how smoking line fits the model, and here this biking line fits the model, and these are the plots for residuals. Okay, so residuals, you can see that there is no any trend is coming. All the residuals are close to this line 0. Most of the points are positive. Half of the points are positive and half of the points are negative. So they satisfy the condition of homoscedasticity and independency or normality distributed. So all the assumption that we have discussed, those are satisfied by the model. Okay, so this is fine. So if someone has any question, one can ask me. So now I'm going to show the same example. So I forgot to discuss with you that how one can plot. That means how one can go those plots in R. So now I'm going to discuss those first for the simple linear regression model. Then I'm going to discuss with you how one can do the same operations that we have done in Excel for the multiple linear regression model. So for the case of simple linear regression model, we have seen those plots, but how one can you can say modify those plots as per our requirement. So these are the commands. That means I'm using this ggplot function in which I call my independent variable income and dependent variable happiness. So when I execute this plot, okay, you can see that now the points are more you can say easily visible as compared to the previous plot. So basically ggplot is a tool that helps you to increase the beautification of the graphical representation, right? So further I want to assign different colors, or I want to construct a line, so I can do that. I have constructed regression line on this scatter plot by using these commands. So I will share this command, but just for your understanding, I'm executing it. So here you can see that after executing this command, you will also get your regression equation in this graphical in the plot also. So one can do those things in R, because R is a you can say open and free software, right? So one can do multiple type of things as per his or her requirement. So this is the beauty of our software. Okay, so here you can see I have assigned titles to them with this scatter plot with the regression line. So now coming to the second data set that we have just discussed now. So first I call the dataset using this command read.csv, because I have saved the dataset in CSV format. Then I derive the correlation. The correlation of biking and smoking is coming very less. Why I'm doing so? Because I want to see that my variables biking and smoking, whether they are highly correlated or not. If they are highly correlated, that means I have some problem with this. I can't directly implement my multiple regression model. So because there is a one requirement that the variables should be independent to each other, so that assumption is satisfied in our data set. That's why we go with this multiple regression model. So after that, I have constructed the histogram. So from the shape of the histogram, it seems like a bell-shaped curve. I can proceed further. So this further command plot show the graphical representation, that means scatter plot between disease variable and biking variable. Then similarly, the scatter plot between disease variable and smoking variable. Then I'm fitting my this linear regression model in which I'm considering heart disease my dependent variable, biking and smoking as my independent variables. Okay, when I execute this, and I want to see the summary. In the summary, you can see the same output that we have discussed in Excel. We got the same things. So we got the value of intercept as this thing, 14.98, biking negative correlated with heart disease, smoking is positive correlated, and all these three are significant. And the value of R square that was same as 0.97. Adjusted R square is 0.97, and the overall model is significant that we have discussed in the Excel under the NOVA table. Okay, and if someone wants to see different plots for the residuals, so one can see that. So when I click here, so this is the first plot, residual versus fitted value. Okay, so here you can see that fitted values are shown here, residuals are shown here. Okay, so they are randomly scattered. So if I want to see the next plot, I have to just enter here. Then I can see my QQ plot, and most observations lies on this straight line. So I can assume that assumption of normality is there. So these observations are outliers. I can exclude them because I have very large data sets. So for the remaining data set, all the observations on the straight line. So we can say that data set is normally distributed. The next plot will show that fitted value and standard residuals, square root of standardized residual. So that is again scattered one. So that satisfies the assumptions that is required for fitting this multiple regression model. Then further what we have is, okay. Now I want to beautify this graphic representation. I want to predict these values. Let me show the output. Okay. So I have plot heart data. That means I am plotting heart disease corresponding to biking. Then I want to add my regression equation here. So what I'm doing here is I have created three categories of smoking here, and these three categories are shown through lines. Okay, so this is again the beautification that if you want to do some modification by categorizing the data set further, you can do it in R. Okay, so after that I have one more. Okay, so you can see that in this plot, you can see your equation for the regression equation also with this. Okay, so this thing, this customization can be done in R. So we can't do such customization easily in Excel. So this is the beauty of our software. So now the session is open for discussion. So if someone has any doubt, one can ask me regarding today's session. But one thing is that R, to learn R, one has to be very much, it means ready, that one has to write a code for each and every function. Hello, can you hear me? Hello,
Sir,
Dr. Meher, are you there?
sir, hello, sir.
Yes, sir. I am here in this side.
Okay. So if there is any question from the audience, I think we should discuss those things.
Hello, sir.
Yes, yes.
Sir, are you going to give us the data set so that we can Try
Yes,
and
yes,
practice
so you can
and
practice them.
so that we can see if we can follow everything you have shown us.
Yes, yes, yes.
Okay, thank you, sir.
Okay.
Dear participant, if you have any question, please, you can unmute your mic and put your question. Dear participant, please, you can unmute your mic. Yeah, Tizani Adam, you can open your mic.
Okay, good morning, sir.
Very good
Morning.
morning. Yes, please put your question. Any question, please?
Hello.
Yeah, please put your question.
Okay, sir. I'm
Yeah.
asking about if there is any outlier or if there is any data that is away from the mean. How can we solve this one?
So basically, there are techniques available to remove those outliers. So outlier means you can, if you have very large number of observations, that then removing outliers is not a problem. But when you have very small number of observations, then it may be that the problem will appear. That if you remove the outliers, then you will lose also the information, right?
Yes, sir.
Any more question, please, from the other participant? I request to, if you have any question, you can put in chat box, or either you can open your mic. You can unmute yourself.
Kindly give the feedback so that we can, I can understand whether what are the message I want to convey to you, whether that message is conveyed in proper manner to you or not.
Yes, anyone can unmute the mic and you can directly put your feedback. If anyone to share your experience during this session. Sweta, Dr. Anuradha, Sadhu Singh, please, Dr. C.P. Thakur, anyone? Or any suggestion, please? Shari Dixit?
Yes, sir.
Yeah.
Yeah, I want to appreciate our professor. Since yesterday, he has been able to take us through how to do analysis of data, regression analysis, whether the assumptions of the linear regression model is being followed. And today again, we have also added multiple regression when we have more than one independent variable. I want to appreciate our professor. He has done very well. Like I said, we will be able to know if we have really understood, if we can lay our hands on the data and practice by ourselves. That's my take. Thank you very much, sir.
Okay, thank you.
Any more question, please, or any feedback? Or any kind of query, if you have, you can ask now. Preeti Prohit ma'am, you can also unmute your mic. If you have any question, please. Okay, I think there is no more question from the participant side. Thank you, dear professor, for this valuable session, and all the content which you present here are really very useful for data analysis. And by using the Excel and R software, both has been discussed, and I think the participant will use all this, and the content which has been presented during the session will be uploaded and will be provided to all the participants so that they can do some experiment on this. And the content which has been presented are really very useful to the entire all the participant, because sometimes when it is required for the data analysis in social sciences and humanities, always we face some challenges, and the most important thing is that the tools and the uh, formulas like correlation, regression, multi-regressions, all this has been discussed in very detail and very clearly, and all the questions has been also discussed. I hope that the session is very really wonderful, informative, knowledgeable, insightful to all the participants. And thank you to all the participants as well as today's our resource person, Dr. Harmanpreet Singh Kapoor. Two sessions has been covered for the data analysis, and the all the entire content which are required for the data analysis in social science and humanities has been covered. Dr. Kapoor, we are acknowledged and honored for your explanatory contribution as the keynote speaker on data analysis, social science and humanities research, simple linear regression, assumptions of linear regression, testing of hypothesis regression, coefficient with the expression. These areas has been covered at the international faculty program is advanced research methodology for social sciences and humanities, held from January 17 to 30, 2024. This program is jointly organized by the Sardar Patel University, India, Purima University, Jaipur, City University, Ludhiana, India, Nexus University, South Africa, English Language Teachers Association of India, Jaipur chapter, and Mathematic Thinking Foundation, Fazilka. So once again, thank you, dear professor, for your valuable time during these two sessions.
Thank you, sir.
Thank you. And thank you to all the participants. The feedback link has been shared in the chat WhatsApp group. And it is requested to all the participants to please submit timely. Assignment will be not assigned for the today's session because both the sessions yesterday and today's are similar type. So today we are not assigning any assignment. Only you need to submit your feedback form. Thank you to all, and tomorrow we will join the session at the same time. Thank you to all. Now it is time to end the session. I request to Prem Kumar to end the session. Thank you to all.